Hi everyone, so this is a MAT 2014 question 4 video. I'm just going to basically finish off the 2014s tonight. I'm quite tired, so expect some mistakes in this one, but I just want to blast through this really. It's quite a nice one as well, actually, this, especially if you can visualize D moving. I actually quite like this kind of geometry. Maybe sometimes you just stumble on the answer quickly, I don't know, like, because, yeah, I mean, well, let's get into it. I mean, like, I looked up, I've actually got my solutions in my hand for this first part, and I'm laughing at the way I did it because I used cosine rule, and just straight away you can see that that's a really silly thing here. Just looking at it again because I've just kind of got my head around it again. Surely the quickest way to get the area of the triangle ABC here is to do a half base times height. Now, the height of that triangle is going to be dictated by, if I can use the sine of that angle. I wonder what that angle is. Well, if that's alpha, because this is a nice isosceles triangle, because, it's got two sides of equal length. So that's a 180 minus 2 alpha. So that must be 2 alpha because it lies on a straight line. And so surely then, if I want to work out the area of the triangle ABC, the area of ABC will equal a half times by the base, which is 1, times by the height. Now, what's the height of that here when that side is 1 and we've got a right angled triangle here? Well, the answer is sine 2 alpha, because sine 2 alpha there equals opposite over hypotenuse, like so yeah, you just get a half sine 2 alpha. I mean, I've written almost nothing down there. I've just kind of spoken out loud my reasoning. I'd write a lot more down in the exam just to kind of demonstrate that that's true, but it just seems really obvious there. Please do write more down than that in the exam, justify it. How would I suppose I should describe quickly how I justify it. I think I'd actually write down, you know, ABC is clearly 180 minus 2 alpha. So if you consider another point down here, label it E, let draw a little diagram and explain what you're doing basically, like let the examiner know. People who are who are marking, they just want to see evidence that the kid really understands why it's that. And if you found a cheeky way of doing it, do it. But yeah, I've got a cosine rule way of doing it written down here. What a silly way of doing it. Okay, so next part. Let F equal area of triangle ABX divided by area of triangle ABC. So we're doing, this area. Let's actually get rid of some of the horrible annotations because it's getting in the way now. Although I'll probably need to use those angles soon. But yeah, you see what I mean. It's that area. If you've got into this problem, and I hope you have before watching my video, because what's the point otherwise? But it's that area divided by the area of ABC. So, it's included in the area of ABC, and therefore F is certainly going to be between 0 and 1. Straight away, I can see why it's between 0 and 1, that's for sure. It's because the area of triangle ABX is definitely less than the area of triangle ABC. I'm going to pause the video actually and quickly see if I can get my GeoGebra image of this up because it will really help, I think. Okay, so hopefully that's worked and you're now looking at the little picture I've got of this. So the point I wanted to make is, as think of ABC in this throughout this question as fixed. Essentially, think of alpha as fixed and think of beta as the one that's changing. Well, certainly initially beta is greater than alpha in this question. Now, as you can see, look at the triangle ABX there as I move D around. Obviously, when D's right the way down here, where the angle BAD is approaching 90 degrees, in other words, where the angle beta is approaching 90 degrees, that's where ABX turns into what's called a degenerate triangle, which just means, the points are all collinear and the area is 0. But then as you move beta up, obviously ABX is getting bigger and bigger and bigger and bigger and bigger, bigger and bigger and bigger and bigger and bigger until you get beta equals alpha, and that ratio is going to equal 1. So that's why it's stuck between 0 and 1. Let's go back to the question. So yeah, I mean, in terms of what I'd actually write down here, once again, I'd write down a lot more, like like I did than in part one. But I try and explain that let's put it like this: when alpha equals beta, you know, what do we have here? We've got AXB is exactly the same area as ABC because it's exactly the same triangle. You know, you've got literally D on C when alpha equals beta, and so F equals 1. And then as we go in the opposite direction, we can see as beta, as beta reduces, as beta gets smaller, the X point slides down, and I can also say the area of AXB definitely reduces, and I can tell you that just by thinking about this as like half base times height again. You know, X is definitely going down in terms of how high it is above A and B there, directly down. And so for each unique beta value, like you're going to have an X value at a certain height, because the way you work out the area of this triangle is 1 times a half times by the height that X is, the vertical height that X is above the line AB. You know, you can see therefore that you're going to have, you know, every K in the range 0 to K to 1, there's going to be a unique beta. Do you see what I'm saying there? Like, the difficult bit obviously is getting it across to the examiner and getting full marks here with your explanation. But as beta gets smaller, the X point slides down and the area AXB also reduces. Since area of AXB, this is a terrible explanation as well. I wrote a lot more down in my solution, which isn't perfect. Like I say, I was faffing about. I'd love to take a screenshot of it actually, because you'll see I'm a bit more careful than I am in my videos when I'm doing these explanations, because I get bored and I want to do the maths in the next bit. But and I figure I've already said it. But yeah, as beta gets smaller, the X points slide down, and area AXB also reduces, since area of AXB, is determined by the height of X above AB. Which must reduce C diagram. My God, my handwriting's getting terrible as well. So yeah, I mean that's my point basically. As this comes down, I don't know if they, maybe they just wouldn't like the way I put this. I'd also like to say like when X gets to A, this all happens as beta obviously increases as well. Like this starts when beta is alpha. As beta increases, eventually it gets to pi over 2. And at that point, AXB is 0. I'd love to actually look. I'll be honest. I haven't actually looked at the mark scheme before I got on here. Like, so I don't know exactly whether like this would be good enough, or how many marks I get for it. But I always figure with these explanation questions, just try and justify yourself and make it clear that you understand what you're talking about. Hopefully that qualifies. I don't know. Okay, part 3. Find the value of beta such that f equals a half. Well, this isn't too bad either. If I can just go back to my GeoGebra thing for 1 second. So yeah, obviously the area is going to be a half when that is at right angles, and I mean AXB here. Let's see if I can get a right angle on here. AXB needs to be as close to 90 degrees as possible. Well, it needs to be 90 degrees, but when I'm doing it with my hand, it may not get to 90 degrees. Let's see. What am I even moving? I'm just moving the letter Y. Let's try and move. Oh yeah, I need to pull D. Sorry. Well, you get the point. I will be here sometime trying to do that. So yeah, the point is, once that's at 90 degrees, then this area AXB is clearly going to be half of the area ACB, because look at it. I mean, like, it's symmetrical. It's split down the middle. You've got a right angle there. That's clearly an area of a half. So we need an area of a half. So what are we going to do? Well, let's just draw a little picture. When this is like this, we need to actually add a little bit to the diagram. You know, it's like annotating the diagram is really useful in these questions. Now, we know that's going to be, let's just put D on there, at 90 degrees. This is C and this is D. Oh, lol, this is D. Sorry, it's late. And yeah, and this is alpha. Well, what are we going to do to work out the value of beta here? We need, this is beta obviously. It's a bit ugly here. I should have probably done this on GeoGebra as well. I don't know if I'm, you know, I don't know a way of annotating the screen. I'll have to look into that. Okay, so what have we got here? We've got AXB is 90 degrees. Just label X there. We've got ABD is isosceles. And that's because that's a 1 and that's a 1. And therefore that's going to be a beta up there. That's well worth considering. And then beta is therefore going to be the same as 180 minus 90 minus alpha over 2. And that's because we've got an alpha here and we've got an alpha here, because these two must be the same there because you've got a 90-degree angle. And so obviously if that's alpha, then that's going to be sorry, 90 minus alpha. What am I talking about? And so that's why we've got, yeah, if you look at this triangle here, you've got 180 minus 90 minus alpha over 2, because this is an isosceles right angle isosceles triangle. That must equal this beta here, if you see what I mean. That beta must be the same as, or if you like, both of these betas must be the same as 180 minus 90 minus alpha. Or if you like, 2 beta plus 90, I'll rearrange it for you. 2 beta plus 90 minus alpha equals 180. Yeah, and that can rearrange into that if you like. That's essentially what I've done. I hope that convinces you, therefore, once you simplify this, that beta is going to be equal to 90 plus alpha over 2. Okay, that's part 3. Part 4, I quite like this actually, this bit. I really didn't mind this at all. And part 5 wasn't too bad either. I quite like this as a question. For part 4, we've got, and let's just draw another picture because really that one's not so serviceable anymore. It's got a lot of writing on it. Let's see if we can just draw a fresh diagram. It's going to be a lot of the same angles though. Picture is so useful in maths, it really is. Okay, alpha, beta, and what do we got here? We've got beta up here, we've already decided that. We've also got x in the middle here. Remember, we're trying to find in this part of the question the area of AXB over the area of ABC, I believe. This is A, this is B, this is C, this is D. Yeah, ABX triangle over ABC triangle. That's the ratio we're trying to find here. Now, the ABC triangle earlier, we already found out was a half sine 2 alpha. So that's good news. So it's really just the AXB triangle which we've got to get sorted out. Now we can't treat this as a right angle anymore. It didn't say that, you know, that was just in the specific case where f is a half. So we need the general case. Okay, so what I did here first was I kind of thought, well, you know, just work out some angles. Obviously, you know, we really want to be working out some angles here. If that's beta and that's B, you know, well, yeah, let's look at this big triangle here. If that's beta and that's beta, well, obviously it's going to be 180 minus 2 beta. We could work out, I suppose, other things, but really I'm thinking about like the area of triangle AXB here. And so I'm thinking it's going to be something like, well, we really need to know the side AX, I guess, yeah? Because if we know the side AX, then I can work out the triangle, area of triangle AXB using sine rule. Now, why would I think it's a sine rule? Well, look at the question. You know, like there's a lot of signs in there, so maybe it's something to do with sine rule. You know, like that's what I'd be thinking here. But you know, it's the only way I've got of working out a triangle which involves some sines. So seems like a sensible way to start. Now, how would you work out the length of AX? Because that's going to be critical if we can then use sine rule just basically straight away to find area of AXB. Well, you know, you could once again think kind of the sine rule, quite literally the sine rule, and say, well, AX over sine of 180 minus 2 beta. Oh yeah, you know what that's the same as, by the way, don't you? That's the same as sine 2 beta. You know, sine of like 180 minus you know, anything is always the same as the thing itself. And that's just, you know, we use that rule all the time, don't we, when we invert a trig function, a sine function, like you know, we straight away to find the next answer do 180 minus, like it's a symmetry in a sine graph. So straight away I can say that that bottom I'm going to change into sine 2 beta in a second, but AX over sine of that equals now what should we do here? Let's do 1 over the sine of this angle here, which begs the question, what is that angle over there? Let's have a little look. We're going to have like, well, this all needs to add up to 180, doesn't it? So I guess this must be 2 beta minus alpha, because then all three of these add up to 180, I think, because the minus 2 beta cancels with the 2 beta and the minus alpha cancels with the alpha. Okay, so sine of 2 beta minus alpha. I'm feeling pretty happy with myself as well when I do this, because when I get AX, I get sine 2 beta, because like I say, that's just sine 2 beta, over sine 2 beta minus alpha. And just look at the question once again. What do you have hanging around in there? Both those things. Good. Looks like we're doing it right. And then, yeah, you just finish it off basically, because the area of AXB, if I can just write casually AXB, the area of that is going to be equal to AX, which is sine 2 beta, over sine 2 beta minus alpha, multiplied by 1, multiplied by the sine of the angle in between, which is alpha. That's just sine rule. You know, and I need a half in here, don't I? Blimey, that's poor. You know, a half AB sine C, as they say. You know, a half times by one side times by another side times by the sine of the angle in between. That's all that matters really with sine rule. So, right, I think I can now work out F. F has got to be this area, which is a half times by sine 2 beta over sine 2 beta minus alpha sine alpha. Oh, and this is over ABC, which is a half sine 2 alpha. And so what's going to cancel here? Not a lot. The halves. And we could write this, I suppose, as well, as we're dividing by sine 2 beta minus alpha and then dividing by sine 2 alpha. We could write this down as sine 2 beta sine alpha over sine 2 alpha, which I hope is the final answer. I can't remember now. Sine 2 beta sine alpha. Did I have 4 terms? I've missed a term. Where's my other term gone? Oh, my God, yeah, look, I've missed the sine 2 beta minus alpha on the bottom. Praise the Lord for show that questions where you can notice things like that. Okay, is that the same now? Yep. You know, I think it is. Sine 2 alpha on the bottom. Yeah, cool, perfect, it is. Sorry, so part 5, write down without further calculation the expression for the area of ABX and hence the formula for F when they switch beta and alpha around. Yeah, they've switched beta and alpha around. That's what's happened. Beta and alpha have switched around in the order of the inequality. Let's take a quick look what that looks like on GeoGebra. Okay, so now we're over here. Look, my little X point has disappeared. But remember how they defined it earlier in the question. They said, and I think I can just remove this. They actually said, let's go up a bit. What is X, yeah? the triangles ABC and ABD intersect in a triangle, any triangle ABX, which means all of a sudden X is over here. Yeah, do you see that? So before I've got an X because I've told GeoGebra exactly, like, it's going to be that point. But now it's now going to be this point here. So let's add another point to our diagram. Yeah, that's a new X, if you like. So let's rename it. Okay, right, that is our new X, and oh, I've lost my beta angle as well. Beta is now alpha, and alpha is now beta. I'm going to basically, yeah, it's nothing. I've confused GeoGebra, but all of a sudden that chops that down. It's because I used X for the angle earlier, but yeah, you've got to imagine this angle is now beta, and the big angle is now alpha. Yeah, and we're now dealing with this thing here, yeah, this triangle. So we're dealing with the ratio of the area of AXB to ACB still. It's still the same description for F. And so it's going to be when it's right the way over here, when alpha is 0 now, when the area is 0. It's going to be when alpha is basically beta, when the area is 1. Yeah, that's what's happening. Okay, let's switch from GeoGebra again. Okay, so it's given us a little hint here, like by saying, look, find an expression for the area of ABX first. Now, ABX is new area. This isn't going to take us long, actually, because we're now over here. And so if I can just draw the new one on, yeah. What is going to be the new area of ABX? Well, you're now using beta. You're not using alpha anymore for ABX, but otherwise it's going to work out really, really similar, because guess what? All the betas have been swapped for alphas in this problem. When you do that, you can basically swap all betas for alphas. Look at the inequality. The beta has been swapped for the alpha. They're now playing reverse roles. This is a symmetrical problem. That's the way I describe it. It's a symmetrical problem where switching alpha and beta means I can now just switch alphas but for betas there, for finding the area of ABX at least, because ABX now is beta here, alpha up there. Their roles have just reversed, and so now all I need to do is just go, okay, well, the new area of this is just going to be swap all betas for alphas in my old ABX formula. Now remember, don't swap it in the F, because ABX was something separate, and ABX was, I believe, a half times 1 times by a sine. Let's just say this is old ABX. I'll write down old ABX first before we switch to betas for alphas. I'm just writing it so I can see it. 2 beta over sine 2 beta minus alpha. So this is what I wrote down a second ago, multiplied by sine alpha. Okay, so that was sine rule on that little triangle. But now, new ABX, well, we're just swapping all betas for alphas and alphas for betas. So we get a half times sine 2 alpha sine beta over sine 2 alpha minus beta. And when we divide to find the new F, well, some things are going to cancel this time, which didn't happen last time. So be careful not to be caught out on this step. I think the original time I did this question, I remember being caught out on this very last step where I just ignored, I swapped alphas for betas and everything, including the area of ABC. But that doesn't change, of course. The area of ABC is still given by that angle being alpha, if you see what I mean. So that's still going to be half sine 2 alpha. And so that sine 2 alpha cancels with that sine 2 alpha up there. That cancels with that. And you're left with just sine beta over sine 2 alpha minus beta, I believe. Just checking my notes. Yep, that's right. Okay, hope you enjoyed that video. Hope it was useful. And best of luck in the MAT coming up soon.